Okay, good morning, everyone. Today, my plan is actually to answer all your questions about the review. So I will not be introducing any new material as a prep for your exam tomorrow. So did you guys start the review? Did the review? What questions do you have about anything? Okay, I give you a minute or so to get to look things up and see if you have any questions. Okay, this is from the book or the review, Chris?
It's from the review.
Okay. $14, $12, and $10. So we go in order. Okay. 14, 12, and 10. All right, so we start from 14. And as we're doing them, if anybody has any other questions, please put them on chat. So the first question is find the surface area of the solid obtained by revolving the graph of f of x equal 8 square root of x between x equal 9 and x equal 20 around the x-axis. Those problems are actually, you just use the formula. You don't really have, yeah, I take all kinds of questions today because I'm not introducing anything new, okay? So it's number 14 from the review. Find the surface area of the solid obtained. So we have the function f of x equal 8 square root of x. You don't necessarily have to draw the picture, but I draw it because I like graphs. Between x equal 9, x equal to 20. So this x equal to 9. This is x equal to 20. And we're going to revolve around the x-axis. Okay. So revolve this piece. And we're not revolving the region. It's only the piece. So we have just a surface here. And the question is to find the surface of this object. So this little piece is not needed in my graph.
What?
That's what we need. Okay. So let's do that. So what's the surface area? So the formula for the surface area is the integral that's around the x-axis from a to b to pi times the function, the value, times the square root of 1 plus the derivative squared dx. And that's the derivative. So to do that, we have first to find f prime. So let us see. This is f of x. It means x 8 times x to the power a half. So the derivative equal 8 times a half, which is a 4, x to the power a half minus 1. So a half minus 1, it means minus a half. All right, so let's compute the surface area. 2 pi is a constant. And now my integral are from 9 all the way to 20 of f of x, which is 8 square root of x, or x to the power a half, 1 plus f prime of x squared. So f prime of x is 4 over the square root. So when I square it, I'm going to have 16 over x dx. Okay. All right, now I need to find the antiderivative of that. Okay, who have any idea how shall I proceed?
Use
substitution.
Oh, okay. What shall I substitute for you?
Wouldn't u be 1 plus 16 over x?
Okay. Maybe a bit problematic. So I'm going to write what you said and see what the problem would become. So the du is the derivative. So this is 1 plus 16 x to the minus 1. This is 0. So it's minus 16 x to the minus 1 minus 1 x to the minus 2 dx. It means minus 16 over x squared dx. Okay. What do you think? Is it going to work? Is the substitution going to work? What do you think?
This is where I got stuck.
Right, because substitution will not work.
Could you multiply the square root of x with the 1 plus 16 over
Yes,
x?
that would be a better approach. You know, integration, as we're going to go back to it very soon, we called it the techniques of integration. How about differentiation? We call them rules. Because differentiation follow very much rules. Integration is harder. It's technique. So every integral, even though it seems like substitution because that's what we did, but definitely it fails because I have an x squared, I have a square root of x. There is no way I can reconcile it. So this is going to fall apart. And if you got stuck, and rightfully so. So now I'm having suggestions. I have one suggestion on chat, and the other classmate is giving me another suggestion. Now the 8, I can take it out, giving me that. And here you can proceed 2 ways. Once your class is telling me multiply those square root by each other. So I'm going to really do that. So because you see, we have the algebra rule, the square root of a times ab is square root of a times the square root of b. So this rule we can apply. So we're going to multiply this. It's going to give me x plus 1 over 16 over x dx. Okay, now what's the benefit of that? Now what's the benefit of this? The benefit is the following. X that distribute plus x times 16 over x dx. Okay, so now become a simple problem. So it was a little bit tricky because our intuition was, okay, substitution totally failed in this problem. So the idea is that we have to multiply, as you guys suggested, multiply the radical. And now my problem is fairly trivial. Now my problem is simple. Now you can use a simple substitution if you want. You can put u to be x plus 16. The du is the dx. And if I change the limit, so limit change, if, let's see, x equal 9, it gives me u equal x plus 9 is to 25. And if x is 20, you will give me 20 plus 16, which is the 36. And this will transform my integral into the following integral in u. The 9.
Professor, shouldn't it be 16 pi still?
What?
In front of the integral, shouldn't it be 16 pi?
Oh, thank you very much. And so the 9 turns into a 25, and the 20 turned into a 36, leaving me the square root of u du. Okay, and now it's simple. I mean, we've done this like a million times. So it's 16 pi times. Antiderivative of that is 2/3, because as you know, we can rewrite it as u to the power a half, u to the power 3/2, evaluated between 25 and 36. All those constants can be basically factored out to make the problem simple. And then I will have 32 over 3 pi times 36 to the 3/2 minus 25 to the 3 half. And finally, the rest is just basic algebra. I will have 36 to the power 3 half, it means 6 to the power 3. Now 6 to the power 3 it's too early in the morning to do it in my head. So 6 to the power 3 is going to give me 216 minus, that's 5 to the power 3, which is 125. So I will have 32 over 3 pi times, let's say 1, and 21 take away 12, that's a 91. And then you guys know how to finish, okay? So the difficulty here was recognizing that the substitution is gonna fail in this particular problem. Questions before I move on? So we back up, so we're moving backward this time, and number 12. So now it's the arc length given by the graph of. So we have the function f of x equal 1/3 x to the power 3 half from 0 to 60. And this time is the arc length. It means just the length of the arc. We're not rotating anything. So 1/3 x to the power 3 half, that's basically a curve going up like that. That's 60, that's 0. And I'm not rotating, I'm just finding the length of this curve. All right. So let's do that. So the length, formula for the length is the integral from 0 to 60, the square root of 1 plus the derivative square dx. So to be able to apply it, I need f prime. So let's find f prime. So f prime is 1/3 is a constant, I keep it, times x to the power 3 half, the derivative is the power, x to the 3 half minus 1, a half. 3 and 3 cancel each other out. I will have 1/2 x to the half. So that's the derivative. So that's a half here. So now we're going to square it. So that's going to be the integral from 0 to 60 of the square root of 1 plus 1/2 x to the power a half squared. Yes. Now we're squaring it. Give me 1 plus a half, basically that's the square root of x, times a half square root of x, it gives me 1/4x dx. So once now this is a substitution, there is really nothing into it because we're gonna have the u to be the 1/4x. My du is 1/4 dx. It means my dx is a 4 du. And then I will change the limit because those problems are easy. So changing limit is not problematic. So I'm going to change limit. If x takes the 0 value, my upper limit will be 1 plus 0. So my lower limit. When my limit is 60, the u will become 1 plus 1/4 times 60. It means 1 plus, let's say 1, 15, 16. So my new limit will become, this would become the following. The integral of 1 to 16 square root of u, and the dx is 4 du. Okay, and then the rest, I think you guys should know how to do that by now. Times 2/3 u to the power 3 half between 1 and 16. And then it's 8/3, 16 to the power 3 half minus 1. it means 8 over 3. Now 16 to the power 3 half, it means 4 to the power 3, which is 64 minus 1. And that's going to give me 63 over 3, which is a 9. 9, it's equal to 72. If I didn't goof anywhere. Okay. Any question about those? All right, so those problems usually have to apply the formula and integrate. So it's really about knowing how to integrate. Okay. All right, so I have 14. We did that, 12, we did that. We have number 10 and then 2BG, 4B. Okay, number 10. Right. Before I do number 10, I have to make one comment in for the spring, work done on the spring. In the formula f of x equal kx, x is always the amount of stretching. It has nothing to do with the actual length of the spring. So it's amount of stretching. And when we find the work, so if you have the spring and you move it from point A to point B, so this is my spring, that's the equilibrium position. That's the equilibrium position. And if I move it from here to here, then that was the force, the X. But what's important is that the A here is how much we stretch it beyond the equilibrium. And the B is to how much we want to stretch. So this is how much we stretch. It has nothing to do with the actual length. And why this comment is relevant will show up in this particular problem. Okay, so I will read the problem and I will do it. So they tell me the natural length of a certain spring is 16 inches. So that's how much its natural length. It means at rest, that's how much. So, and a force of 8 pounds is required to keep the spring stretched 8 inches beyond its equilibrium. Find the work needed to stretch the spring from a length of 18 to a length of 24. So let us really read the problem again. So we have the spring right there. And its natural length, it means when it is at rest, is 16 inches. Okay, so this is at rest. Okay, and the first thing they tell me that if you stretch it 8 inches, so that's the first information they give me, 8 inches beyond equilibrium, and you hold it, so you stretch it 8 inches, then the force here required to do that is 8 pounds. Okay, and then the second question, that's what's given. That's what gave us. And then they're asking us the following. I read again what they are asking us. They're asking us is, find the work needed to stretch the spring from a length of 18 to a length of 24. So what happens if you stretch it from a length of 18, so that's mine. If I want to stretch it from a length of 18, and I want to stretch it all the way to a length of 24. But the 18 and the 24 is the whole length, from a length of 18 to a length of 24. What's the work needed? All right, we're gonna do it step by step. Step number 1 is to find the work, I need the force. I need a formula for the force. And the question is, did they give me enough info to find the force? Yes or no?
Yes.
Yes. What the info they gave me? We know that The formula that governs the force is that the force is always K times the amount of stretching. That's the formula for the force. That's not the work. So what kind of info they gave me to be able to find K?
They gave you f of x, so force, and then the distance that it was stretched, which is x.
Yeah, so how can I set this up into an equation to solve for x? Equal 8. So f of what equal to 8?
8.
F of 8, because if you stretch it by 8 inches, you stretch it by 8 inches, right? Then the force is 8 pounds, right? Am I copying the number correctly? Yeah. If you stretch it by 8 inches, the force is 8 pounds. Now, one issue is that unit. Since we don't use inch as unit, we have to transform 8 inches into feet. So let us convert 8 inches into feet, because the unit of work is either Newton meter, which is a joule, or it's foot pound. And inches does not really work very well. So 8 inches to feet, what's the conversion? So when I first convert 8 inches to feet, remember what's the conversion?
Divide by 12 inches.
Right, because 12 inches is a foot. So we need 8 inches to feet. So it means 8 over 12. 8 over 12, which is going to give me by 4. That's a 3/2 of a foot. Okay, so this gives me that f of 2/3 is equal to 8. So I just have to convert into feet to be able to do the problem. So that's what give me f of 2/3 equal to 8. It means if you take k times 2/3, that's equal to 8. It means my k is 8 times 3 over 2. It means my k is 12. So the force now is 12 times x. So whatever, if you stretch your spring, you are at a distance x from the equilibrium, you want to hold it, the force you need is 12 times the amount you are stretching it by. So this is just the force. I'm listening.
I have a question real quick.
Sure.
So where did you get the 8 from on the right side of the equation? I know on the left side you got it from 8 inches.
Yeah, I read the problem. A force of 8 pounds is required to keep the spring stretched. This 8
okay.
That skates from coming from here.
All right.
Did you read it?
Yeah, no, I was just wondering because I thought I used the 8 and 8 inches twice. I was confused.
No, it's just by coincidence I used 8 in the problem to mean different things. So this is 8 pounds here, and this is 8 inches. Okay?
All right. Thank you very much.
No problem. Now, the work. What's the work? The work is the integral from A to B of the force, which is now we have a formula for it. Now, what is A and what is B? We want to move it from 18 inches, from a length of 18 to a length of 24. But A should represent the amount of stretching beyond the equilibrium. So if we're gonna stretch it from a length of 18 to a length of 84, it means we're gonna stretch it from how much beyond the equilibrium to how much beyond the equilibrium. That's what we have to ask ourselves. So 18, it means we are, if this is the equilibrium, that's the 16. That's equilibrium position. It means we're stretching it from 2 inches beyond the equilibrium to how much this should become. I'm taking away the 16 from here. So if I take the 16 from here to 8 inches beyond the equilibrium. Now the problem I gave you, Don't we usually need to convert to meters when we do physics? No, because you convert to meter if the force is given in Newton. If the force is given in pounds, but then you have to convert to feet. Okay, so it depends what the force is given. It's given
Okay,
to
got
you.
it.
Yeah, okay. So now the work. The work we have to go from, because now they give us the whole length. So the 18 inches include the length. The formula tells me A should be the stretching, how much you stretch beyond the equilibrium. So if now we're stretching from 2 inches, now in foot, 2 inches is 1/6 feet, you divide by 12, and 8 inches is 2/3 of a foot. So now the work will become, the lower limit is only how much we stretched, not the total length. So I'm removing the total length. So it's going to be 2/3, I meant 1/6, all the way to 2/3 of 12x dx. Okay. So if in the problem, I only give you the amount of stretching. So for example, I tell you, find the work need to stretch from half a foot to 1 foot, then I'm just giving you the amount of stretching. Then you go from half a 1. In this problem, they did not give you the amount of stretching. They gave you the length of the spring. In this case, you have to take away the actual length and just focus on the amount of stretching beyond the equilibrium. Because the x in the formula is the stretching, does not take into account the length of the spring. Okay, so that was the difficulty in this problem. So now finally it's going to be equal to 12 is a constant. I remove it. I will have that x dx. Now antiderivative of x is a half x squared evaluated between 1/6 and 2/3. Now the half could be factored out to make the math simple. So I will have 6 times 2/3 to the power 2 minus 1/6 squared. And the rest you just do the math. Okay. Please ask questions, any questions you want as I move on. Right. So we go back, I'll go back and see the question. Zach, I told you that I take question from last night homework. So if you find them, sorry, I didn't read the whole question. Now from what? Okay, 2b and 2j. So that's the integration part. So it's 2b and 2j and Natalia 4b. And then I go to yesterday's questions. 2b. Okay, we're gonna do 2b. And this is the following. That's the integral of cosine 3t plus a half plus 1/5 cubic root of t. So basically I packed in this problem a lot of antiderivative. All right. So we're going to do them slowly. So it's equal to integral of. So first I look at them and see what's easy, what's hard, and what to do. Cosine 3t, not very hard, not trivial either. A half is a constant, we don't have to worry about it. So actually, let me split them. Plus a half dt plus. Okay, this is 1/5. I have to rewrite it. There is no way I can keep it like this. So how can I rewrite this? So this is, I do that. So I have 1 over 5 the cubic root of t. So this is basically 1/5 times 1 over the cubic root of t. Okay, so this will become 1/5 times 1 over the cubic root of t is t to the power minus a third dt. Okay, so now we have to do it one by one to become very easy. And this I have a little bit to work with it. So I'll leave it for a second. Antiderivative of 1/2, so that's a half times t, and that's a fifth, 1 over minus a third plus 1, t to the minus a third plus 1, plus my constant c. Now, antiderivative of cosine 3t. How shall I do that?
Take the derivative or antiderivative of cosine, and then you have to take the derivative of 3t, like for the chain rule or whatever. So it'd be 3 sine 3t.
No, you are differentiating. You're not integrating. I'm going to isolate that. Usually,
So you'd have to use substitution.
we have to do use substitution. You have to do use substitution. So whenever I have an issue, something that I will do a lot once you go back, I usually isolate the problem which is giving me a headache. The minute I have an inside function, I have to start thinking. That's substitution. So you have to put do not confuse substitution with, integration with differentiation. U will have to be 3t. The du is 3 dt. And this is going to give me integral of, this will be the cosine u. The dt, I have to get it out of here, is 1/3 du. This is the dt. So this is going to give me 1/3 du. And this will end up with 1/3 sine u. So it's the opposite of differentiation. It's not 3 times, it's 1/3. It's 1/3 cosine 3t. Okay, so even if you have like 3 functions, a lot of time, okay, whenever one gives you difficulties, it's not crystal clear. It means not easy to find sine derivative. We have to isolate it and do it on its own. Whenever I have an inside, definitely I have to use a substitution. So this is going to give me 1/3 sine, so that should be 1/3 sine 3t. So it's 1/3 sine 3t. And now I just clean it up a little bit. Okay, now we clean it up. So let us clean this up. This is equal to 1/3 the sine of 3t plus a half t plus 1/5. Now minus a third plus 1, that's 2/3. 1/2/3, so you're going to multiply by 3/2. And then t to the power minus a third plus 1, it's 2/3 plus a constant c. And we definitely stop here. There is nothing else to do. I mean, there is one simple thing we can do. Plus 3/10 t to the power 2/3 plus c. End of the problem. Okay. All right, so let's look at the other one.
Professor?
I'm listening.
So for the third integral, so 1/5 t to the let me see, to the negative 1/3.
Yes.
How did you pull out 1/5 times 1 over negative 1/3 plus 1.
Sure, we can do it slowly, right here. Okay, so we have that. Okay, you use me up to here. 1/5 is a constant. I'm gonna pull it out. And I will be left with t to the minus a third dt. Okay, now this is a fifth, that's a constant. I don't have to worry about it, times antiderivative of t to the minus a third. So here just the power rule where n is minus a third. And that will give me 1 over minus a third plus 1 t to the minus a third plus 1. So it's going to give me a fifth times 1 over minus a third plus 1, that's to 2/3, t to the power 2/3. Now I flip, I'll get a fifth times 3/2 times t to the power 2/3. Does this make more sense?
Yes, thank you.
Okay, very good. Thanks a lot. Okay, so now we move to J. Okay, where is it? Right here. All right. Integral from 0 to 2 of e to the x divided by what? By 1 plus e to the 2x dx. Okay. All right. How shall we do that? I'll give you one hint, and then I stop. Yes, go ahead, talk.
Can you split the equation? So e to the x over 1, e to the, no, never mind. That wouldn't work.
Never
Is
work. Yes.
arctan
We cannot split what? We cannot split what?
You can't split the sum in the denominator.
Right. We cannot split the sum in the denominator. We cannot split the sum in the denominator. Just think about numbers.
Can you use arctan?
Can I use what?
Arctan? Because
How?
like the well, because I'm pretty sure the equation is something along the lines of like the derivative of arctan is x over 1 plus x squared.
How can we make it looks like that?
You assume e to the x is x.
No, you cannot do that by any stretch of the imagination.
Why don't we try substitution?
Why would we try substitution? You cannot imagine ex is x. That's totally doesn't work. I try substitution. If you tell me which substitution, I do it.
Let's make u equal to 1 plus e to the 2x power.
All right, I will do that. Okay, what's going to be my du? Derivative of 1 is 0 plus, what's the derivative of e to the 2x?
2e to the 2x.
2e to the 2x. Okay, now here's my problem. What's my problem?
Oh, we just have e to the x. We don't have e to the 2x.
Exactly. I only have e to the x.
Okay.
I don't have e to the 2x. I have no idea how to pull the e to the 2x. All right. So this has to go. This has to go. I'm going to give you one hint. And I think with my hint, I hope at least, is going to become easier. First, am I correct? Am I correct?
Yeah.
Yeah.
E to the 2x is e to the x squared. Now, what do you think is going to be the substitution that will save us?
Just e to the x.
Now it's e to the x. Okay, u is equal to the x. Now du is e to the x dx. And now the limit are, so limit, change limit. If you don't change them, it's okay with me, but you have to go back to e to the x at the end. If x is 0, the u is e to the 0, which is a 1. If x is 2, the u is e squared, which is e squared. That's it. I cannot do anything about it. So finally, this is going to be the following. Integral from 1, that's the lower, the upper is e squared, and then the ex dx. The ex dx is my du now, so I can go like this, and now I will have 1 over 1 plus u squared. Now, that's an integral in u, absolutely in u, there is no x inside. That's the goal of substitution, create a new one in u, no x inside. That's the arctangent now. That's arctangent u, not arctangent x. And it's between 1 and e squared. So finally, I will get arctangent e squared. I know it's a nasty number, but it is what it is, minus arctangent 1. Now, arctangent e squared, I don't know what it is, and I don't care. I know how to use my calculator. Minus arctangent 1, I should know. What's the angle whose tangent is 1? That's what's the arctangent. It's the angle whose tangent is 1.
Is it
The angle whose tangent is
5 over 4
1
then?
by 1.
Okay.
And of my problem. Okay, so it is an arctangent, but you cannot in your head, okay, put x instead of e to the x. That's not the way it works. Substitution, it was in order. Okay. All right, so now I see I'm going to speed up a little bit because I have 2 more questions and I will try to, I want to do them before I let you go. I have 4B from Natalia and I have number 29. Okay, so let's look at 4B. Okay, 4B. All right. So I read it. Set up the integral to find the area of each of the region given below by, I want it done 2 ways, integrating along the x-axis, which means I have to take vertical slices and horizontal slices. All right, so we're going to take this problem, we're going to graph the function and then proceed. So, and that's only the area, it's not volume. Okay, so tomorrow you read the problem. If it's area, area. It's volume, volume. Do not confuse them. So now it's only area. Y equal x plus 8. Y equal 8 minus 2x. And finally, the line x equal to 4. Okay. So let us proceed with that. So this is my graph. Nothing could be done without graphing. I have no idea what anything looks like here. So x plus 8, so that's a line. The intercept is at 8, so that's really my intercept right here, that's my 8. And it's a line, it's positive, so it's a line going like that. That's the first one. So that's x plus 8. Now 8 minus 2x. Again, the intercept is at 8. And this one goes down because the slope is negative. Goes like that. And it will be nice to know this point because it's we'll have a better graph. So what's this point here? This point is when 8 minus 2x equal to 0. And it's going to give me x equal to 4. So 4 happened to be here. So the line x equal to 4, I'm looking at this region right there. Okay, sketching a good region is absolutely crucial to those problems. So this is really my region, right? To be able to proceed any further. Okay, we'll proceed any further later on. So first we're going to do integration with respect to x. With respect to x. So integration with respect to x, it means I want x to be my variable. So this means I need to take those slices. So it means we need vertical slices. All right. So the question here, all right, if I take a vertical slice, what's the upper curve? What's the lower curve? Is the upper changing? Is the lower changing? So we have also to look at this question. So in this particular problem, this is my xi in here. And the question is, regardless where I took my slice between 0 and 4, my upper curve is always x plus 8. So that's always my upper curve. And my lower curve is always a minus 2x, regardless where I take my slice. So regardless where I do that. So with respect to x, it's going to be the integral from 0 to 4 of my upper curve, which is x plus 8, minus the lower curve, 8 minus 2x, that's the height, times the width of my rectangle, which is the delta x. Okay, so that's with respect to x. Now with respect to y, I will sketch another picture to be clear with respect to y. So I'm going to graph it again. So okay. You guys done?
Yeah.
So I'm going to graph it because, we need those slices. I don't want both. So this is again my graph. And this is my 8, which is my intercept. And this was my 8, my other intercept. And this was my 4. And this is my region. And remember, the rectangle you take have to be inside your region. Some student last time, they said, okay, she takes rectangle, but the rectangle were outside the region. It doesn't really make much sense. They have to be inside my region. So now this is my 8. We knew that. And I need to take horizontal this time. So with respect to y. Means I want y to be my variable. So now I have to take the horizontal slices. So that's really an area problem. I'm not rotating. I'm not doing anything. I'm just going to take my slices. So since I take my horizontal slices, I'm dealing with area. I have really to worry about the left curve and the right curve. So now what is my issue here?
At one point, you get different bottom limits.
Not bottom, be careful. I'm taking those slices. So it's not really bottom. What do we call it?
Or would it be upper?
No,
Left,
no.
I guess.
That's not the left.
This
It's left
is
and right.
near.
It's left and right. You hear me? It's right curve and left curve. It's not up and bottom. So that's my delta x, that delta y here. So I worry about what's my left, my right curve, and what's my left curve. Okay, up and bottom is when we're doing that, those vertical slices. And so here we realize what's going on. The right curve is always this line. So it's 4, no question about it. The left curve is changing. It's sometimes this one and sometimes that one. So since I'm doing with respect to y, I need to express everything in terms of y, and I need to find the intersection right there. So we have a lot of work to do. So this is y equal x plus 8. So I need to solve for x because I'm thinking horizontal. So x would become y minus 8 for this one. This one down here. It's y equal 8 minus 2x. So we have to solve for x. So I'm bringing the x to this side. It's going to give me 8 minus y divided by 2. Okay, that's that. Second, I need, remember, right now, my variable is y. So I'm basically splitting my region this way. So I can call this S and I can call this R. So I need the area of R plus the area of S. Okay. All right, now let us analyze the way we've analyzed it before. Let us note here. For y between 0 and 8, between here and here, my right curve is 4. And my left curve is this one, 8 minus y divided by 2. Now, for y between 8 and this point that I didn't find yet, what's this point here? If x is 4, the y is 16. So that should be 16 up here. So between 8 and 16, the
Would it be
right,
12?
12, yeah.
12.
of course. Why did I put that? I don't know. Okay, because I want to hurry so I can answer all your questions. This is still F4. My left is this one here. That's the left one, which is y minus 8. Okay. Once I do the setup this way, I don't really have issue. So this is going to be equal to, for R, it means this region, that should be the integral from 8 all the way to 12 of here minus the right, which is 4, minus the left, which is 8 minus y dy. So y is my variable, plus the integral from 12, S is from 0 all the way to 8 of 4 minus 8 minus y over 2, the whole thing dy. And of the problem, okay? All right, so I think I have, time is up. So for those who would like to leave, feel free. And for those who like to stick around, I can look at 6-7, number 29, okay? So it's really up to you guys. Remember, tomorrow, the exam will open, so you come to Brightspace at 7:30. So I'll give you, so you guys will have plenty of time to do. So please, on Brightspace, tomorrow at 7:30, I will open the exam at 7:30, and I will be here. So I will be with you. So I will wake up early tomorrow, and I will be there at 7:30. I would like your camera on. You guys are becoming very, you're shutting this camera. Just, as I said, it's hard to teach without seeing faces. Okay, so as I said, those who want to leave, you are free to do that. For those who wants to stay with me a little bit to do number 29, section 6.7, you're welcome to do so. Any questions for those who wants to leave?
Have a good day.
Thank
Yeah,
you.
I have a question.
Yes.
Will the rest of the lecture be recorded so I can watch it later and do the
Yes,
review?
yes. I'm not going to stop the lecture. Yeah.
Okay.
I mean, it will be only one problem. Yeah, I'm not stopping the recording. Yes.
Okay, thank you.
Yes.
All right. Have a great day.
Bye-bye, guys. So I will have, so it's going to be only one problem, and it's 6.7, number 29. Okay, let me open the book. Okay. All right, calculating work for different springs. Calculate the work required to stretch the following spring 1.25 meter from their equilibrium position and assume Hooke's law applies. So let me look at the problem, read it here. Calculate the work required to stretch the following spring 1.25 meter from their equilibrium position. So we're going to stretch it 1.25. Assume Hooke's law is obeyed. It means f of x equal k times x. A spring that requires 100 joule of work to be stretched 0.5 meter from its equilibrium. So the setup here is the following. Okay. We have a spring. And so that's part A. And 100 joule, that's unit of work is needed to stretch how many? 0.5 meter from equilibrium. And the question is, find work needed to stretch the original 1.25. Okay. So this is the question. So to find the work to stretch 1.25, the work is nothing more than, it's the integral. So I want to stretch it 1.25 from this equilibrium. I want to stretch it 1.25. It's going to be the integral from 0 to 1.25 of the force. Since it's a Hooke's law, it means the force should have the form kx dx. So to be able to answer the question, I need to find a formula for the force. So the formula for the force, it means I need to find a k. So that's really the goal. That's my goal. But the question is, we need to find k, the constant k. And usually the problem should have in it information to find the k. All right, so did they give us any information to find the k? Back to you.
They gave us work
joules
and distance.
and 0.5 meters.
Right, so how shall I do that? So the 100 joule represent what?
F of x.
Read the problem again.
I mean, the force.
Read the problem again.
It's the work.
It's the work. Read the problem. What's this 100 joule of work is needed, not force. Part B is the force, we will do that. They tell you 100 joule of work is needed. So the 100 represent the work needed to stretch 0.5 meter. It means the 100 is the integral. It's the integral because it's a work from 0 to 0.5 of kx dx. Okay, because in this particular problem, they did not give us information about the force. I think B is the force. They give us information about the work. So we have to read. So the 100 represent work, not force. Now I use that to solve for K. How do I do that? My K is a constant. I can get it out. And then I will be left with that. Equal 100. Now I solve for K. So it's going to give me K times antiderivative of X is a half X squared evaluated between 0 and 0.5. This is equal to 100. Okay, so it's going to give me K times, okay, 0.5 squared, it means 1/4, sorry, it means 1/4 times a half, so it's going to give me K times 1/8 is 100, which will give me that K is 800. Hopefully I didn't do any stupid mistake. Did I do anything wrong? I hope not. So this tells me that the force now is given by the formula 800x. So now I know the force. Now I can go back to answer the question. So now the work is to stretch it 1.25 is the integral from 0 to 1.25 800x dx. And now I compute that. 800 is a constant. I can get it out. Then I will have a half x squared evaluated between 0 and 1.25. And then you can finalize the answer, right? So that's for part A, because part A, they gave you 100 represented the work, not the force. Now we look at B. B is B. What is B? B is so B is the following. A spring that requires a force of 250 to be stretched, blah, blah, blah. So I read B. B, they tell you that a force of 250 Newton is needed to stretch the spring. How much? 0.5 meter beyond equilibrium. And the question is, find work required to stretch 1.25 meter. Okay, so how shall I do this problem? So I need, that's what's given to us. That's what's given. And that's that's my goal. Okay. To find the work, I need a formula for the force. That's pure and simple. So we're gonna write f of x equal k times x to be the force. And what we need, so that's my goal, is to find the integral from 0 to 1.25 of f of x dx. But they did not give us the formula. They did not give us, I know that's the form of it, but I don't have to, I need to find the k. So how can I find k in this problem?
Now f of x is 250.
Now f of x is 250 because they gave us the force. You have to read the problem. Okay, you read the problem. So now we know that f of, and that's needed to stretch. So that's amount of stretching. Now f of 0.5 is 250 because they give us the force. The rest is simple. If you take k, multiply it by 0.5, you are gonna get the 250. And then k is going to be the 250 divided by the 0.5. It's basically, it's like multiplying by 2. This will give me a 500. So the formula for the force now is 500x. Now I have the force. Now I compute the work. So you have just to read the problem. It's not hard. It's just reading carefully. X dx. And now finally, you find the antiderivative. 500 is a constant. Antiderivative of that is a half x squared between 0 and 1.25. A half can be basically pulled out, which is going to give me 250 times 1.25 square minus 0. And the rest is just simple. Whatever this is. So this is whatever it is. It is 1.5627 times 250. So if I'm doing my math correct, means if I'm plugging in number correctly in my calculator, I'm getting 390.625. And my unit is Newton meter, so my unit is joule. Okay. All right. Any other questions before let you go?
I just got a quick question on
Yes.
compressions. So for Math Lab, when it wants spring compression, it's asking us for a decreasing limit, but you just want magnitudes, so it's okay if we use a normal increasing limit, right?
Yes, I think it's easier for you to understand. That's why I did it this way. Okay.
Okay.
For me, but the way MATLAB is doing it is are going from 0, whatever this is, to minus 0.5.
Yeah.
Something like that. You can, that's correct, of course. But I found it a little bit not very intuitive for the student because the upper limit is smaller. So I like to think of compression. Basically, the force, the direction of the force is this way. And the motion is also this way. So why don't we just orient ourselves so the direction of motion and the force works the same way. If we do that, then our intuition work. If we compress it from here to here, we're compressing it from here to here. So we're dividing this into pieces and adding the little bit of work. It becomes from 0 to 0.5 of whatever, kx dx. Okay.
Yeah, I like it better that way anyway.
I find it a little bit more intuitive for the student, more understandable in a way. That's my opinion. And the book does it like this, 0 to whatever. I mean, they call this minus 0.5 because the book, and 0, and then they take you from 0 to minus 0.5, which is, I mean, absolutely correct. But I find this a little bit easier for you. Okay, any other questions? Okay, so good luck for tomorrow. Be there at 7:30. And if you have any other questions, I have office hours this afternoon, and you can email me in case you get stuck at some point and you don't have access to me. Okay, bye-bye, guys.